For tonight's homework, please complete page 7 and correct it with this option. All right, so let's start by making a tree diagram to determine how many lunches are possible. You're going to start by choosing a sandwich. So let's pick our sandwiches here: chicken, hamburger, turkey. Then I'm going to go ahead and pick a vegetable. So there's 2 vegetable options, carrots and spinach. So I'm going to have a carrot and a spinach coming off of each one of my sandwich choices. Next, I'm going to have the fruit. So fruit, I could have apple or banana. So I'm going to have an A and a B coming off of each vegetable choice. Today my pen is not working well, so I'm having to write with my finger. So I'm sorry that it's a little bit messier than it usually is. So I know it's a little tricky to see, but there are branches that go with each of those vegetable choices that lead into the fruits. So now I'm going to write my combinations. So I could have 4 different possibilities here with a chicken sandwich, right? So chicken, carrots, apple, chicken, carrots, banana, chicken, spinach, apple, chicken, spinach, banana. Again, I'm just following straight up through here: chicken, carrots, apple. I'm going straight through and following the branches. Then I've got my hamburger options. So I've got hamburger, carrots, apple, hamburger, carrots, banana, hamburger, spinach, apple, hamburger, spinach, banana. And now I'm on to my turkey options. So again, I've got turkey, carrots, and then over here, apple, turkey, carrots, banana, turkey, spinach, apple, turkey, spinach, banana. And so how many outcomes is that? Well, again, using the counting principle like we were starting to introduce today and like you're going to see tomorrow, there are 3 sandwich types, there are 2 vegetable types, and 2 fruit types. So to find the total number of outcomes, I can also use this thing called the counting principle to say 3 times 2 times 2, that makes 12. And sure enough, over here I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible combinations. So what are the chances that Saul's going to get his favorite lunch? He prefers chicken, carrots, and a banana. And so looking here, I see 1 option to make that happen, 1 out of 12. What about at least one of his favorite items? So here I'm looking for how many of them have chicken. Here's these 4. So all those would work. How many of them have carrots? These guys have carrots. These guys have carrots. How many of them have an apple, or I'm sorry, a banana? This guy has banana. This guy has banana. So there's 2 lunches that would not work, but that means the chance of him getting a favorite item, at least one of them, would be 10 out of 12, which I can simplify as well to 5 out of 6. Let's start by making a tree diagram of the possible outcomes for the spinner and the number cube. So starting with the spinner, I can get either a 1 or a 2. Then I'm going to roll my number cube. So here I could get 6 different things: a 1, a 2, a 3, a 4, a 5, or a 6. So I'm going to go ahead and draw those same 6 branches coming off of 2. And I know it's hard to fit them all on there, but just do your best. So then I'm going to list all my outcomes as well, just because that's helpful to know. So I get a 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, and then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. So how many different combinations are there? Well, there's 2 possibilities on the spinner and 6 possibilities on the cube, so there's a total of 12 possible outcomes. What are your chances of getting a 2 on both the spinner and the number cube? So the probability of getting a 2 on the spinner and then a 2 in the number cube, well, here I can see I have 122 out of 12 possible outcomes. What's the probability that you get a factor of 2 on both the spinner and the number cube? Well, again, factors are the numbers that I can multiply to make a number. So factors of 2, for example, are going to be 1 and 2, right? Because 1 and 2 is a way to make 2. So looking at this, I have 11 here, which would be factors of 1 and 2. 12. I'm looking through because I want a factor of 2 on both of them. I have 21. I have 22. So I see 4. So again, my probability of getting a factor of 2, so P factor of 2 on both is going to be 4 out of 12, or 1 out of 3. What's the probability you get a multiple of 2 on both the number cube and the spinner? Well, so now multiples of 2, I'm going to think like a multiplication chart. So multiples of 2 are going to be 2, 4, 6, 8, etc. So looking over here, again, multiples of 2, I'm going to think about how I need to have, let's see, I'll pick a different color here. So I'm looking for these guys. So for example, 1 and 1, 1's not a multiple of 2. So anything with a 1 in the beginning, unfortunately, is not going to work for me. Then looking at this guy here, so 2 and a 1, well, 2 is a factor, or is a multiple of 2, but 1 is not. So 22 would work, 24, and we also have 26. Because I know that 4, for example, is a multiple of 2, and 6 is a multiple of 2. So P, multiple of 2 on both. I'm sorry, this writing is so bad today. We would have 3 out of 12, which is equivalent to 1/4. That's it for today. We'll see you tomorrow.